Everyone, so today's problem of the day is number of ways to assign edge weight 1. What is given in description? There is an undirected tree with n nodes labeled from 1 to n, rooted at node 1. The tree is represented by a 2D integer array edges of length n minus 1, where edges I equals to ui comma vi indicates that there is an edge between node ui and vi. Initially, all the edges have a weight of 0. You must assign each edge a weight of either 1 or 2. The cost of a path between any node u and v is the total weight of all the edges in the path connecting them. Select any one node x at the maximum depth. Return the number of ways to assign edge weight in the path from node 1 to x such that its total cost is odd. Since the answer may be large, return it in modulo 10 to the power 9 plus 7 and ignore all the edges not in the path from node 1 to n. So we will be given one tree, undirected tree. Suppose it is something like 1, 2, 3, 4, 5, 6, something like this. It will be given 6, 7, and 8, something like this. It will be given. So we need to find, first of all, we need to find the maximum depth node. If we are done finding the maximum depth node, then we need to find from the root node, that is 1, till this depth all the edges. There are total 3 edges. So we need to find how many ways are possible to assign the total odd sum weight to these edges. Like we can assign either to 1 or either to 2. We can assign to these edges. So we need to assign 1 or 2. So we have 3 edges. So in how many ways we can assign the 1 or 2 weight to these edges so that the total sum will be odd. So if for 3 edges, what can be the possible sum? Possible sum can be 1, 2, 2. The edges, the total sum is 5. It can be 2, 2, 1. It can be 1, 2, 2. It can be 1, 1, 1. So total 4 cases are possible for this. So the answer will be 4. So we need to return this only. You can understand more with the help of example. So since will be given 1 and 2. So this is the root node, and there is only one child node. So we don't need to find the depth in this case, because depth is obviously for maximum for this node, because there is only one node. Then there is only one edge. So how many ways to assign one, or we can assign 1 or 2 only. So how many ways to make the total sum as odd? So in this case we can assign only 1. So the number of ways is 1 only. If we will talk about the second example, so this is the maximum depth is, you can see maximum depth is either this or this, but in both cases the maximum depth is same. So we can consider any node. The maximum depth is 2. So it is irrespective of the node. We need to just find the maximum depth. If maximum depth is 2, so we can consider any. Suppose we consider this and this. So 2 edges. So how many ways we can assign 1 or 2 edge weights, so that we can either assign 1 or 2. So that the total sum will be odd. So we can do 1, 2, or we can do 2, 1. We can't do 2, 2 and 1, 1, because the total sum will be odd in both these cases. We want total sum as it will be even, so we want only odd, so we can only take this and this. Number of ways will be 2. So if I think you have now the better clarity of the question, but before jumping into the solution, we first check the constraint. According to the constraint, we will try to build a solution. The constraint is like n can go maximum till 10 to the power 5. That means we need some answer in big O of n or big O of n log n time complexity maximum. We can't make any solution of big O of n square. So if we will see, we'll try to understand the question. It is first question is clear. First doubt is clear. Like it is not depending on the nodes, that what is the value of the node, which node. It is just depending on the number of edges between the root node and the last depth node. So if the 3, then there will be the fixed number of ways. So we will try to find for few edges. If we will try to find for 1, it will be only 1. Because 1 we can fill 1. If we will fill 2 in that edge, then it will be even. We need odd, so we can fill only one. So 1 is the way for 1. For 2, 1, 2, and 2, 1. Because we need odd sum. We can't do 1, 1 and 2, 2 because it will be even. The number of ways for if the number of pages will be 2, it will be number of pages will also be 2. For 3, 1, 2, 2, 2, 1, 2, 2, 2, 1, 1, 1, 1. There will be 4. And for the 4, it will be 8. So there is a pattern in this. So if I will see there's a pattern, one for 1 it will be 1, for 2 it will be 2, for 3 it will be 4, and for 4 it will be 8. So it is creating a formula like the number of depending on the number of ages. So it will be 2n minus 1, where n is the number of ages. So that the same thing I have done in my solution. I declared the number of ages plus and plus 1. If we will do, we will get the total number of nodes. Then I have created the adjacency list. Then I pushed all my nodes in my adjacency list. Then I am trying to find the maximum depth. And in the maximum depth I have passed this adjacency list 1 and 0. What is 1? 1 is the node because I am starting from this node. And why I have used this 0 here? Because to show that my parent, 0 is showing my parent, there is no parent, so I have just declared 0 because the node value is starting from the 1. So what I will be doing, I will use my DFS here to find the depth. So initially the number of edges will be 0, 0 resultant equals to 0. Then I'm starting traversing from my root node to other nodes. If my this next node is the parent of this node, because this is undirected tree, so the next node can be the parent also. So if it is not the parent, then I can do res equals to maximum of result comma 1 plus solve, and I will switch my next node. This IT will be my next node, and my parent node now will be changed to X. And at the end I can return result. This is to find the depth. But if I will now what I need to find the number of ways. To find the number of ways, the formula will be 2 to the power n minus 1. So n will be my maximum depth, because this for this I am finding my number of ages, so that ages I can use in my this formula. So the same thing I have done to find the 2 to the power n minus 1. I have passed this 2 is my x and this n minus 1 is my y. The same way what we are doing for the power, that same thing we will be doing for in this question. Like initially the resultant equals to 1, and if I will try, if my this value is odd, suppose y and 1, that means if that y this value and of 1 is equals to 1, that means my this value is odd, this power. If my this power is odd, then what I can do, I can do resultant equals to, I can add 2 in my this value, and I can decrease it by divided by 2 value I can decrease. And suppose I can do 2 into 2 and minus 1 by 2. We can understand in this way. I can multiply the same value here, and I can divide this value by 2. Divide I am doing with the help of this. This will equals to y divided by 2. So at the end I can return my answer result. And if it is even, we can directly do x equals to x into x. And at the end, I'm returning this value only. So yeah, thank you.